Hello and welcome. In this video, we will learn the various operations used in relational algebra. After watching this video, you should be able to explain the fundamental operations of relational algebra. We access the data by using certain database applications such as Microsoft Excel, Microsoft Access, and others. These applications communicate with the database through SQL and a database management system that is responsible for managing the application. SQL has its own querying methods to interact with the database, and these queries work in a similar fashion to relational algebra. However, the operators in relational algebra are not necessarily the same as SQL operators, even if they have the same name. For example, the select statement exists in SQL. It also exists in relational algebra. However, these two uses of select are not the same. Because a database management system will take SQL statements that a user types in and translates them into relational algebra operations before applying them to the database. So what is relational algebra? Relational algebra is a procedural query language. It consists of a set of operations that takes one or two relations as the input and produces a new relation as their result. There are 6 fundamental operations of relational algebra: select, project, union, set difference, Cartesian product, and rename. Your select and project operations are called as unary operations since they operate on a single relation, whereas union, set difference, Cartesian product, and rename operations are called binary operations since they operate on pairs of relations. Now let us take a look at each operation of relational algebra in detail. Select is used to obtain a subset of the tuples of a relation that satisfies a select condition. The notation used to represent a select statement in relational algebra is shown on screen, where sigma stands for selection predicate, R stands for the selection of relation, and P is a Boolean expression in which rows are selected only if the condition is true. Now let us take an example for a select operation. Take a look at the student table as shown on screen. By applying the Boolean expression shown on screen, it selects the rows from student table where the name is John. With select operation, we can also use logical operators such as and, or, and not. With select operation, we can also use relational operators like equal, greater than, lesser than, and others in Boolean operations. Now let us take a look at what a project operation is. A project operation is used to select a subset of the attributes of a relation by specifying the names of the required attributes. The notation used to represent a project statement in relational algebra is shown on screen. Pi stands for project predicate, and A1, A2, and AN are the attribute names of relation R. Now let us look at an example for project operation. Consider the student table shown on screen. By applying the Boolean expression shown on screen, it selects and projects attributes of the names and hobbies from the student table. Now let us take a look at what a union operation is. A union is used when we need some attributes that appear in either or both of the two relations. The notation used to represent a union statement in relational algebra is shown on screen. R and S are either database relations or a relation result set. R union S gives a set of all the tuples that belong to either R or S. We say a union operation is valid if it satisfies the 3 conditions. R and S must have the same number of attributes. Attribute domains must be compatible. Duplicate tuples are automatically eliminated. Now let us take an example for a union operation. Consider the tables student and professor that are shown on screen. By applying the Boolean expression shown on screen, first it projects the student and professor's names. It then combines the names of the students and professors by eliminating the duplicate values. Now let us take a look at what a set difference operation is. Set difference finds tuples in one relation but not another. The notation used to represent a set difference statement in relational algebra is shown on screen. R and S are either database relations or a relation result set. Here R minus S finds all the tuples that are present in R but not in S. And S minus R finds all the tuples that are present in S but not in R. Now let us take an example for a set difference operation. Consider the tables of students and professors as shown on screen. By applying the Boolean expression shown on screen, it finds all the names that are present in the student table but not those that are in the professor's tables. By applying the Boolean expression shown on screen, it finds all the names that are present in the professor's table but not those that are in the student table. Now let us take a look at what a Cartesian product operation is. A Cartesian product combines the information of two different relations into one. The notation used to represent a Cartesian product statement in relational algebra is shown on screen. Here R and S are two relations where R product S is the set of all the concatenated tuples. Now let us take an example for a Cartesian product operation. Take a look at the tables that are shown on screen. By applying the Boolean expression shown on screen, it produces the Cartesian product of the student and professor table. Now let us take a look at what a rename operation is. A rename operation allows us to rename the output relation. The notation used to represent a rename statement in relational algebra is shown on screen. Now let us take an example of a rename operation. Take a look at the student table as shown on screen. By applying the Boolean expression, it selects and projects attributes of names and hobbies from the student table. And the result of expression E is saved as new. Now let us do a quick recap of this video. In the beginning, we saw what the definition of relational algebra is. Relational algebra is a procedural query language. It consists of a set of operations that takes one or two relations as the input and produces a new relation as their result. The next thing we learnt about is the fundamental operations of relational algebra, which are select, project, union, set difference, Cartesian product, and rename. The select operation is used to obtain a subset of the tuples of a relation that satisfies a select condition. A project operation is used to select a subset of the attributes of a relation by specifying the names of the required attributes. A union is used when we need some attributes that appear in either or both of the relations. A set difference is used to find tuples in one relation but not in others. A Cartesian product will combine the information of two different relations into one. The rename operation allows us to rename the output relation. Thank you for watching this video.